Here I'll show the steps for constructing a confidence interval for the population proportion P. You'll want to find the point estimate P hat, and sometimes that requires dividing x by n. We'll need to verify that the sampling distribution of P hat can actually be approximated by a normal distribution. To do that, we have to make sure that np hat is greater than or equal to 5 and nq hat is at least 5 as well. Then we'll want to find the critical values. We always use ZC with binomial experiments rather than T. We'll need to find the margin of error using a formula that is for population proportions. And then, just like in the other cases that we had looked at, we want to add and subtract the margin of error in order to find the bounds of the confidence interval. Let's try this one. It says in a survey of 1,000 US teens, 372 of the teens said that they own a smartphone. Find a point estimate for the population proportion for all the teens who own smartphones. Then construct a 95% confidence interval for the true population proportion P of all US teens who own smartphones. Now, just for review, P hat is calculated by dividing x by n. That gives us a P hat of 0.372. We're going to want to draw ourselves a normal curve here. And let's verify that it's valid to use a normal curve approximation to this binomial experiment. Because remember, binomial experiments are discrete. They are stepped functions. And so they're not truly normal curves. But as long as we have NP and NQ large enough, we can treat them as if they were normal curves because they'll look just like a normal curve, but one that's just very finely stepped. So n times p hat will be 1,000 times 0.372. That's going to be 372, definitely bigger than 5. And then we'll need NQ hat, which is going to be 1,000 times 0.628. Which is 628. So there's no question the normal approximation can be used. Okay, with that in mind, we're going to want to draw an axis here, and we put a dot right in the middle. Now what goes in the middle? P hat goes in the middle. So 0.372. That's the point estimate, the best estimate of P. It's going to be a 95% confidence interval. So let's go ahead and draw those boundaries. And then let's draw the corresponding parentheses. Okay. This is our interval. Our next step is going to be to find the ZC that corresponds to a 95% confidence interval. So we'll go to the tables. Let's use the Z table. The ZC that corresponds to 95% confidence interval is 1.96. Okay, great. Now we want to find the margin of error. The margin of error formula for a binomial experiment here is going to be ZC times the square root of P hat Q hat over N. Let's plug in all our values. We'll do that on calculator and find our margin of error. It's 0.03. All right, now we need to take our P hat and we need to add that margin of error, and we'll also subtract the margin of error. 0.342 and 0.402. That's our confidence interval. So now we can put it in words. With 95% confidence, the true population proportion P for all U.S. teens that own a smartphone is between 0.342 and 0.402, which would be 34% and 40%.